In this recording, we're going to look at mindful manipulation of percents. This is going to be pretty challenging, but I think really valuable that we go through this carefully and try to understand the relationship with the various growth rates that exists. Okay, so because these, as it says in this paragraph, because we're talking about exponential growth, it's going to be a constant multiplier effect instead of a constant additive effect. We're adding the same amount each time. So let's look at a couple examples. This first one is a population of wombats. Okay, it says it has a constant percent rate. So what's happening is we have 1,027, and a year later we're up to 1079. So we know that it's growing exponentially because the constant percent rate. The question is, what is the yearly percent growth rate? Let's figure that out. So the first thing we got to do is find out how much they went up. So the population grew by 52 wombats. And now we have to find out, okay, relative to how many they started with, at 1027, how many is that? Well, we're just going to do that percent, and it comes out to be about 5.1%. Now let's try to determine the percent growth rate at the wombat, can't even speak, the percent growth in the wombat population over a decade of time. Okay, so 10 years. What are we talking about? Okay. So what's going to go on here? Well, we've got our wombats. There's 1,027 of them. And we're going to be growing them at 1.051 is our growth rate. Where's that coming from? It's right from here, right? Taking our growth rate, writing it as a decimal, and adding it to 1 because we're increasing. We're going to go for 10 years. Okay, so we get 10 years here, decade. 10 will be our exponent. So far, so good? Okay, so go ahead and multiply this portion right out here. Okay, I don't even need this number. I'm going to kind of ignore that number. Okay, and just do 1.051 to the 10th power. And that's going to work out to if we're going to the nearest hundredth, 1.64. All right, so basically raising this growth rate to the 10th power. Now I can see what our growth rate is, what we should be multiplying by. Okay, so the factor is 1.64. And over here it says, well, okay, what's the percent growth rate? Well, we know that it's always 1 plus the percent, so it's really 64% that it's growing by. Okay, sticking with our wombats. Alright, now it says, okay, assume it's constant growth rate, alright, constant percent here. What is the monthly growth rate to the nearest 10th of a percent? Okay, so let's figure out that. Well, you can think about this a couple ways. One is to just say, okay, I'm going to take that 1.051, and instead of raising it to the 10th power like we did before, to find out what it would be after 10 years, say, okay, what would it be just after 1 month? So that's a 12th of a year, right? So if I do that work that out, it comes out to be like 1.0042 is our multiplier. And so if you think about it, that would be the 1%. So that's like 0.00. No, I don't have that right. Let me back up. It's like 0.4%, right? Because that would be the 1% place, and this is less. It's 0.4%. All right, next question. Population's growing at a constant rate of 22% every 5 years. Interesting. So therefore, what's it going to be over a 2-year time span? Right. So this is going to be hard, but we can figure it out together. So let's first figure out what it would be for a single year, given that it grows 22% in 5 years. So I guess one thing I'm going to think about is, okay, what's the multiplier if it grows 22%? So if you'd say, okay, that'd be 1.22, right? 22% turned into a decimal, added to 1. And that's going to happen over 5 years. So if I only want a single year, I'm going to raise it to the 1/5 power. That's what it's going to be in a single year. Now, over 2 years, okay, I'm going to take that amount, 1.22, and essentially raise that to the 2nd power. Or in other words, multiply those two exponents. Okay? When you do that math, it comes out to be 1.083. And you can see, okay, that's going to be 8.3% growth in the 2 years. Pretty cool. Okay, in this next example, we're looking at world oil reserves. Okay, we know that's a serious problem in our modern society. They're actually being depleted, which is another fancy way of saying it's decreasing, at 2% per year. And okay, so after 20 years, what's that going to look like to the overall effect on our world oil reserves? It's obviously not going to be 2%. It's happening many times. Okay, so first off, what are we going to multiply by? Well, we're going to start with our 2% decrease. So we're going to be 1 minus 2%, or 0.98, right? Remember, this has to be less than 1 if it is a decay. We're going to go to 20 years, right? And the question is, okay, what's this going to be? Well, multiply that out using your calculator. So doing that work, we get around 0.6676. Now the question is, okay, what is that? It's not a 66%, 67% decline, right? Because that's the growth or the decay factor. So it's really 1 minus that amount, 1 minus 0.6676. So do that math, and it comes to be, to the nearest percent, about 33% of the world's oil reserves we will have depleted in 20 years. We like to do radioactive questions because they're an interesting example of exponential decay. So, half-life situation. Okay. Well, we know that we have a half-life of 20 years, meaning in 20 years we're going to have half as much. Okay, so what would it be after 40 years? Well, in this case we've got our base of half, right? And let's find out what it would be after 1 year. Okay, so after 1 year it's going to be 0.5 to the 20th. And now we're going to raise all that to the 40th. And you might say, well, isn't 40 divided by 20 just 2? Couldn't we have just squared it and set it 25%? Yeah, you could have. Okay, so that makes a lot of sense. Kind of checks with what we had thought about intuitively. All right, and so, okay, after 10 years, what are we talking about? Well, this one we're definitely going to want to use our process. So there's our half-life, and it takes 20 years to reduce this amount by half, and so 0.5 to the 1/20. This is after 1 year. Now, if I want 10 years, raise that to the 10. Do that math, and you've got 0.707, or as a percent, 70.7. Yikes. Try it one more time. 70.7%. Okay, and finally, I'd like you to do this one on your own. After only 5 years, what percent will be left? Play the recording when you're ready. Okay, so hopefully you took time to work this one out. There's our half-life. That's per year. But we want to do it to the 5th power because we're going to do this thing 5 times, and that works out to be about 0.8409, or to the 10th of a percent, 84.1%. Thanks for watching.